Hi, I'm Barbara Bernstein from BetterTeachingNow.com, and in this video we're going to take a look at adding and subtracting fractions. So first of all, have any of you heard the expression that you can't add apples and oranges? Here's 2 oranges, here's 3 apples. What would happen if I try to add them together? Do I have 5 oranges? Do I have 5 apples? No, I really can't add them together because they're different things. And when we try to add fractions, this principle comes into play, and I'll show you how. If I was trying to add a half and a half, or 3/4 and 2/4, I'm able to do this directly. The reason is they're considered what math teachers call like things. And I mean by that, this is the word I'm saying, like. They're alike. These are both fourths. This is 3/4, and this is 2 more fourths. So altogether, that adds up to 5/4. So you notice that what a fraction really is the bottom number tells you what kind of thing you're talking about, and the top number tells you how many of those things you have. That is what the numerator, the top number, and the denominator, the bottom number, mean in common sense language. Another way to read this is from top to bottom. You can read it by saying 3, and this line is read divided by. 3 divided by 4. So that you can actually divide that out. 3 divided by 4. And another thing that you can do here to understand this is to picture that you have, let's say, a pie, a pizza pie, an apple pie, whatever, and you have it divided into fourths, 4 even set pieces. And you've got 3 of those pieces. And you're adding to it 2/4 from, say, another pie. So in order to add, what we really do is we add the numerators, and we just do what I call copy down the denominator. It's not being changed because all it is something that tells you what kind of thing you're talking about or working with. In this case, you're talking about fourths. 3 of them and 2 more of them, totaling 5 of them. Here, we're talking about a thing called halves. 1 half and another half make 2 halves altogether. Now notice that when the top number equals the bottom number, you've got 1 whole. So 4/4 makes 1, or 1 whole. 2 halves, if I have something divided into halves, and I've got 2 of those halves, that's 1 whole. And so this really is more than 1. This is more than 1. Because 1, 2, 3, 4, this is 4/4, and the 5/4 means I have yet another fourth in addition to that. Anytime the numerator is greater than the denominator, I've got more than 1. When the numerator is equal to the denominator, I have 1. And if the numerator is less than the denominator, I've got less than 1 whole. Okay, now what happens if I wanted to add a 4th and a half? This is a very easy problem in the sense that it's not hard to visualize. Here's something divided in half. If I divided each of the halves in half again, that would create fourths. And you can kind of see that a half, which is the same as 2/4, and another fourth adds up to 3/4. You can kind of visualize that. But we want to go over the process for how we solve problems, because what's going to happen, as I'm sure you know, is that you're going to get problems with much more complicated numbers that you cannot visualize. So you really need to be able to understand the process and have a rule that you apply, even if you can't see what the answer is out of the, off the top of your head, so that you can compute the answer. Now, in order to understand how to add these, first of all, we can't do it directly because fourths and halves are like apples and oranges. They're different things. We can't add them directly. What we're going to have to do is re-express the problem so that we have two fractions with the same denominator. Once we get the same denominator, we're talking about the same kind of thing, and then we can add directly just by adding the numerators. So how are we going to get this to the same denominator? In order to do that, I have to show you something else. I have to show you how to multiply fractions. So let's suppose that I wanted to multiply 2 times 3. Now you know the answer to that is 6. Now I'm going to show you another way of looking at this problem that will shed light on how we multiply with fractions. I could express 2 as a fraction, and the way I would do it is I would say 2 is the same thing as 2 divided by 1. Is that right? Is 2 divided by 1 2? 2 times 1 is 2, no remainder. Anything divided by 1 is itself. 10 divided by 1 is 10. 8 divided by 1 is 8. So I can always take a number and make it into a fraction, saying it's divided by 1, and I have not changed the value. This is equal to this. Now I'm multiplying by 3, and I'm going to do the same thing with 3. So I've re-expressed this problem this way so that I have fractions. Now I know my answer is 6, because 2 times 3 is 6. But I could express 6 as 6 over 1. Now if you just don't look at this middle piece, but you look at the problem at this side and this side, you can see that what we did was we multiplied the two numerators and we multiplied the two denominators. Let's see if that's generally the case in how we multiply fractions. Let's look at another example. So suppose I wanted to say a half of 8. Okay, when you change an expression with words, like English words like this, into all math symbols, of changes to multiply. So of really means multiply. This is a half times 8. But I could express 8 as 8 divided by 1, again, because anything divided by 1 is itself. So 8 over 1 and 8 are two ways of saying the same thing. They're both equivalent. Now, you know that a half of 8 is 4, because if you've got, 8 popsicles or licorice sticks, and you're sharing with a friend, you're going to get 4, and your friend's going to get 4 if you're dividing it exactly in half. So you know the answer here is 4. Look what happens if I multiply the numerators. 1 times 8 is 8. 2 times 1 is 2. This is 8 divided by 2. 8 divided by 2 is 4, right? This is 4. So a half of 8 is equal to 4. And 4 could also be expressed as 4 over 1, but I don't really need to bother with that. This is another example that shows you that when we're multiplying fractions, we multiply the numerators, we multiply the denominators. So our rule of thumb, I'm going to give you a couple rules of thumb. A over B times C over D. Now I'm using letters instead of numbers because the idea here is that this letter stands for any number and any kind of number. This will apply for positive numbers, for negative numbers, fractions, whatever. Something divided by something else times another fraction is equal to A times C over B times D. And that could be written this way, AC over BD. So now we want to address how this rule can be used to help us compute this sum by getting a common denominator. So the way that we're going to do this is we're going to convert the 1/2 into another way of writing something that has the same value as a half, but has the same denominator as the other fraction. This is equal to 1/4 plus, I'm going to take my 1/2 and I'm going to multiply by a form of 1, because anything times 1 is itself. Multiplying 1 times something does not change the value. Now, if I multiply by 2 over 2, 2 divided by 2 equals 1. 1 times anything is itself, so I'm not changing the value of the 1/2. And what I wind up with, let me do this over here, is 1/4 plus 1 times 2 is 2, and 2 times 2 is 4. So I've used this rule to re-express 1/2 as 2/4. Now I have like fractions instead of unlike fractions that the problem originally stated. So here I'm going to add 1 plus 2 is 3, and I don't alter the denominator. That just tells us the kind of thing we're talking about. 1/4 and 2 more fourths make 3/4. So you can see our rule for adding fractions would be this: a over b plus c over b equals a plus c over b. So when we add fractions, we have to have the same denominator. When we multiply, we don't. To multiply fractions, we just multiply the numerators together and multiply the denominators together. And to add fractions, we add the numerators together and we copy down the denominator, whatever that is. And we can utilize the rule for multiplication to get a common denominator when we don't have one. Okay? Can't add them directly. They're like apples and oranges because fifths and thirds are different things. So I've got to get a common denominator, and if I multiply 2/3 by 5 over 5, I am multiplying it by a form of 1, so I'm not changing the value, but I've selectively chosen a form of 1 that's going to give me a denominator of 15, because I can do the same thing here. Think for a second now, what am I going to multiply here 4/5 by so that I can also have a denominator of 15? Well, 5 times 3 will give me my 15. And if I multiply the denominator here by 3, I've got to multiply the numerator by 3. Because 3 over 3 equals 1, so I'm not changing the value. And another way to think of that is whatever I multiply the denominator by, I must multiply the numerator by. Has to be the same number, and then I'm not changing the value. So this is equivalent to 3 times 4 is 12. 3 times 5 is 15. I already wrote that down. 2 times 5 is 10. 3 times 5 is 15. I already wrote that down. How do I add fractions with the same denominator? This means 12 15ths, or 12 of these things called 15ths. This means 10 of these things called 15ths. 12 of them and 10 more of them make 22 of them. This is 22 15ths. Now, sometimes you can get an answer and it can be simplified in various ways. This actually, is this greater or less than 1? Take a look. 15/15 is 1. Anything with a bigger numerator than the denominator is more than 1. So I could simplify this. This is a correct answer, but another way to say the answer would be to actually do this division, because that's another way of understanding what a fraction means. It means the top number divided by the bottom number. And when we write this out, notice that the top number goes on the inside of this division sign. The bottom number goes on the outside. It's very easy for students to switch those, so you want to remember the top one goes on the inside. Okay, 15 into 22 goes once. 1 times 15 is 15, and the difference here is 7. So this is 1 and 7/15. And this is the answer to our original problem, which was 4/5 plus 2/3. Now, subtraction is kind of related to addition, and it operates the same way that addition does. So if we wanted to subtract fractions, let's say we had a problem like 8/9 minus 5/12. Just the same way that we couldn't add two numbers that were considered unlike, fractions with different denominators, we also cannot subtract two numbers that are fractions with different denominators, because we can't take 12ths away from 9ths, directly anyway. But we can re-express this as having the same denominator, and then we'll be able to do the subtraction very similar to the way we do addition. We just subtract the numerator from the other numerator. But let's take a look at how that would work. So when we're trying to find a common denominator, there are some rules that you can use to find the lowest common denominator, which makes your work a little bit easier because you're not dealing with largest numbers. But you don't really have to work with the lowest common denominator. As long as you get any common denominator, you can do the computation. And I can always get a common denominator by taking each of the fractions that I'm trying to add or subtract and multiplying one fraction by the other denominator, and then vice versa. So if I multiplied 12 times 9 here and 9 times 12 here, I would get a common denominator and I could do the problem. But I can look at this and see that there's something I could do that would make my work a little bit easier. Because really what I'm looking for is some number that I can multiply each of these by and get to a common multiple, essentially. Sometimes a common denominator is referred to, or a common denominator is referred to as the least common multiple, is sort of what you're looking for. Multiples of 12 are 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. 12 times 4 is 48, and so on. Multiples of 9 are 9 times 1 is 9. 9 times 2 is 18. 9 times 3, etc., etc. You can keep on going in this same manner and try and find something that you can get a common denominator to. So I can see by looking at this that I can actually get both of them to be 36, because 9 times 4 is 36, and 12 times 3 is 36. So that's what I'm going to do. 12 times 3 will give me my 36. If I multiplied the denominator by 3, I must multiply the numerator times 3. If I multiply 9 times 4, I'll get 36. But if I multiplied the denominator by 4, I've got to multiply the numerator by 4. Because as long as I multiply, or for that matter divide, the top and bottom of a fraction by the same number, the fraction remains equivalent in value. Because multiplying by the same number on top and bottom is essentially like multiplying by a form of 1. 4 divided by 4 is 1. 3 divided by 3 is 1. So I strategically chose a form of 1 to multiply each fraction by that will generate my common denominator. Okay? This is going to be 32 32, and I'm subtracting from it 32 36, and I'm subtracting from it 15 36. That's a tongue twister. Here's what I'm saying. 36. It's hard to pronounce. 36. I've got 32 of these things called 36, and I've got 15 here. I'm subtracting the 15 from the 32, and that's going to equal 17. 36. Let me just write that out to make absolutely sure I'm not making an arithmetic mistake. This is 17 36. 17 is a prime number. That means that other than 1 and 17 itself, there's no other two whole numbers that will multiply to equal 17. And as a result of that, I know that I cannot simplify this or express it in smaller numbers or in a simpler form. This is going to be as simplified as I can get that answer. Okay, so this concludes our lesson on how to add and subtract fractions.